feel free to comment so that it's not just me and Victor talking.
Yeah.
Did anyone see this paper, by the way?
I definitely didn't or haven't.
Okay.
Yeah, I mean, I don't spend most people to have read it because I just pick it randomly at last minute because I forgot to set the paper earlier. I'll try to set it after today. Then next paper, so people have time to read it if they want. But
yes,
let's just read it ourselves now and figure out what it's about and comment on that. And
yes.
let's skim it a bit. Then yeah, I'll be going through the paper as usual. I'm also saying it because I see there's new people. But people feel free to interrupt and talk about whatever you want about the paper. In the middle. Doesn't have to be just me and Burnie talking about the paper. It ends up being that often, but that's not because that's the ideal format for a reading group. It's just because most people don't want to talk. But if you want to talk, feel free to do so. Or write on the chat. I'll try to pay attention to the chat and.
I found Alpha somebody as well. They posted it directly on their Twitter account.
How does that work? Do they post any paper or do they just post papers that are recently popular or something?
I don't know what the heuristic there, but it's not direct correlation of. It seems like what they post it's more human created, I think, because it's not directly only what's popular on Alphaxif. Wait,
if I saw it
someone tried to. I think. Oh yeah, and they try to They try to reproduce this paper using auto research in Alphaxif here. That's pretty cool.
Okay, so
yeah. Other than that, I don't, or at least Grog didn't find any other Twitter post.
Yeah, I also don't remember when I saw this paper. I just was earlier today residing on a paper, and one of the places I saw was
also,
this.
yeah, and it's June 13th. Okay. There's a small probability that I would converge to this paper while experimenting with flex in LLM. So let's see.
Okay, so let's read it.
Okay.
Finetuning LLMs to get new kernel from a critical challenge. Okay, yeah, so LLMs facts. Destroying facts. Knowing using gap. Characterized by an accuracy gap and a temporal lag between memorization and generalization. Okay, yeah, so this is about models memorizing facts, but yeah, not using, I guess in the sense of repeating them and not using them for other tasks.
Yeah, in multi-hop reasoning, I guess.
Understand this phenomenon of learns with ancient knowledge and monitor this.
I wonder how they do that, because that's exactly what I've been experimenting on how to like as properly as possible fine-tune knowledge into LMs.
Yeah, that was related to something. We should probably talk about that because that's related to the things I was doing with the Going Severance paper and other things I was doing earlier.
And they have code and everything.
I haven't been super productive lately, but I should get back to that. Yeah.
Yeah, same.
Says patching identifies activation locations where okay. Using self-patching. So they have this new technique called self-patching. Self-patching activation locations where the relocating representation substantially improves failed generalization cases.
Localization where relocating representations. This is very interesting. I wonder if they mean like from layer X to layer Y or something.
The results
or
are
if it's
consistent with
somehow changing the vectors, rotating or something.
Knowledge circuit misalignment hypothesis. Memory representations can exist internally, but might not be routed to computation effective layers. To demonstrate
Circuit.
the particularity that is not defined, we design a simple heuristic strategy which covers 58 and yeah. Of the oracle hidden generation failures. Experiments are done across the domain for the rest of defining. Yeah, so they have code. They have code. I think
Yeah,
it's
it
just
seems
anonymous
like all the
because of
code is
the
open.
review.
Yeah. I expect that as well.
Uh,
Okay, I do wonder how exactly, like, if they do when they fine-tune the knowledge, if they also try slightly changed facts and see if they work or not, and using them in different contexts and mixing it with general knowledge so that it doesn't catastrophically generalize as well and stuff like this. They use TLR. Train multifact, train single fact. Train single fact. Specific samples.
okay. Yeah. So
like how the comments in the code are half Chinese and half English.
yeah, there's no reason why the computers was okay. So sorry. No using apps. Is locating entity. But try to okay, so the model can answer things on this shape, but not use them for reasoning. Okay. No using app. Policy app. Decision accuracy remains significantly lower than memorization. But I guess this is the
Reliably use them.
this sounds like the kind of thing where this is only where with chain of thought and reasoning, the model will also get it right. In that it will say the capital of the country is in located this. So if it would ask where the capital of Sydney is located, then it will be like first it will say Sydney is located in whatever, and then will respond. You know.
At the same time, this can also happen in the forward pass itself, since at least in JSpace there's multi-step reasoning in a single forward pass.
I'm assuming that this is talking about. We'll see, but I'm assuming this paper is about like a single forward pass.
Yeah, I wonder if you could apply JSpace here. If you could see the multi-step reasoning in the forward pass. Well, it's still responding inaccurately. Like the JSpace stuff is causal, so I wonder if you would inject the JSpace multi-step reasoning if it's not
I
there.
saw, Borny, that you were
It would fix
responding
it.
to and he responded to you with what was his name? Yes.
Yeah, I didn't expect to get a response from him, but yeah, that's pretty cool. And I learned from that. I think it's like the literature on causal. Yeah, well, the context there is, I asked him about, like, he criticized that JSpace isn't causal enough. I asked, okay, what's your definition of causality? What do you want? And he's like, ablations are not good enough because you can have billions of correlated parts of the model that you also ablate, and therefore you do not really localize it on a particular layer potentially, because it might have been the case that you also influence other parts of the model, so you don't. There's a chance that you really don't localize it properly. Well, and plus some other nuances in the discussion and so on. Yeah, I really want to learn all the causal learning literature because it's extremely complicated, and that's pretty cool. Or maybe it's simple, but it's just a lot of stuff there. Yeah.
Okay. So
Which kind of makes sense because you can ablate multiple circuits for the same behavior at different parts of the model, and you still ablate the same behavior. So maybe those circuits influence each other. Yeah, I don't know. We can read that paper, by the way, if you want, Victor. Next
yeah,
time maybe as well.
which one? Sorry, I was distracted.
Paper that claims that a single behavior has multiple circuits that are
Oh yeah, I think I
causally
saw
relevant.
that. Okay, we can like I'll have some ideas. Later we can discuss more what after the reading group remind me to discuss which papers we're going to read for next week. I think there's a bunch of interesting ones on the. I think that was one of them on the Mech Interp workshop. Maybe I found this one there on the Mech Interp workshop Spotlight.
Yeah. Okay. Potential as well.
Yeah. Also on the interesting findings thing. There was another one about replacing by Python. First, it might be a slope though.
You mean the symbolic regression interp?
Program synthesis interp, where they try to replace attention heads by Python code automatically.
Oh.
That seems interesting, but
SimTorch.
apparently kind of
okay.
meant. But let's go back to this. Sorry. So
I don't know if this is relevant, but I added the paper to a collaborative whiteboard. So if you guys click on the link, we can all just like draw on the paper, and maybe that'll help for like ask questions and stuff.
There is also Discord. Discord has also this app,
yeah,
but I don't know if you can upload paper like this. So maybe uploading paper isn't supported.
Can, but
yeah, we used the Discord drawing a few times before.
Yeah, if you want, I can set up the Discord one.
Yeah, but I don't know if you can just upload the paper like in this other one.
Oh. Yeah, I just use this for reading groups. Yeah, I'm happy to use whatever.
Yeah, I see that you can upload image, but I don't think you can upload file.
Yeah, anyway,
like
so use what
we might use it later.
Use whatever that you want. So anyway, so the paper is about this thing, how this gap between accuracy and between this gap about the model responding to questions about the directly about the thing, and the model responding to chain of thought, like multi-step reasoning things using the fact, where it can do one and not the other. I do think this is probably only on single forward pass, because if you have more forward pass, I will guess the model mostly can solve all of the problems, because if it can verbalize the thing, it will just do that and then answer the question. Kind of like in the what's the name? The reversal course stuff and all that, where there is a bunch of failures of models of doing, single step reasoning, but when you let them do chain of thought, they can just do the chain explicitly, and that works.
This also makes me wonder, like, if they also didn't train it enough or with big enough learning rate, because if you make the learning rate way too high and train it way too much, it will answer that everything is the fact that you just trained it in. So like catastrophically generalized.
I think that's putting too high learning rate and all that. I think
Yeah.
that's a partly a skill issue on your part, so you need to not train
Yeah.
it that hard. And they okay.
But it
Anyway,
seems like if it's correct, they claim that certain mechanisms exist on certain layers and certain facts exist on other certain layers, and they just do not get routed to the computation that uses the facts. Yeah, I don't know. Let's see.
yeah,
Maybe I'm missing something, but I don't think I fully understood the claim of the paper. Also, like, I didn't read this paper, so stop me if I'm derailing anything. But I don't fully understand what exactly the temporal lag is supposed to be here. Is this like so it says is a temporal lag where the generalization emerges significantly after remembering. So what is remembering in this context?
I think remembering would be just that the model accurately says a capital
they
of
give an example here. I think
Francis Price.
the example is the model. You ask a question with the model where the answer is directly the thing, like Sydney is locating it, whatever, and it's just the fact, probably the same shape that they trained, or a similar shape, and the used here seems to be the model generalized into some question. There is like two-step reasoning where it needs to use the fact in combination with some other fact to do some reasoning step. And
Is that what they? Sorry, I didn't mean to interrupt. Go for it.
Yeah, feel free to ask. I love it. That you
yeah,
ask.
By generalization, do they literally mean the model repeats the facts and uses it to answer a different problem? That's what they mean by generalization?
I
that
think
the fact is
here
used
it
in
doesn't
multi-step
repeat the
reasoning.
fact. Yeah,
Sorry?
like
I think yeah.
I think that doesn't, like, for example, so on the Sydney is located in whatever, right? The answer is the fact. On
Yeah.
the capital of the country, Sydney is located is whatever. The fact is not the answer. It needs to do an extra step and output a different token that is not the fact. Like, it needs to know the country and then get the capital from that country.
It doesn't like maybe I'm naive, but it doesn't seem like a very rigorous definition. Like if in other contexts, if I wanted to talk about generalization, I'd talk about like test error.
Here
I
they're
wonder-
talking about. They're not talking about generalization. They're talking about the knowing use gap that they just made up the term. So, and they
but I just wonder how you like know. How you know. It seems kind of like heuristic or subjective.
Yeah, it's
like how you measure that.
Yeah, you can say like the test accuracy. Like in this context, the train is Sydney is located in entity, but the test is the capital of the country Sydney is located is blah blah blah. And you can add more test cases, like I don't know, Sydney is in Australia, right? Sydney.
I mean,
is
I
it in
think.
Australia?
I mean, I think you can measure in
Like-
the sense that
New South
like there is a
Wales.
clear measure of like there is some objective measure of like the performance on some
Yeah,
data
Australia.
with
So-
where
yeah.
answered like this, and in some other data set with answered like that. You can also just think of it instead of thinking of whatever interpretation, just thinking of the phenomenon the paper is studying is why sometimes models that give the correct answer to a data set with this kind of question generalize to this kind of question, some other times they don't, I guess.
Yeah.
Also, to be clear, I haven't read the paper either yet. I'm reading it right now, so I might be wrong
Okay.
about it.
That's fine.
All right. Capital of Australia is not Sydney. Oh, that's the whole point of this. Okay, I actually just
Why is
understood
it
this.
not?
Like, yeah, Sydney is located in Australia, right? Sydney.
Yeah.
The
Sydney
paper says
city,
not
but it is
says
not
Canberra,
capital.
apparently.
Sydney is capital city of New South Wales. Blah blah. and it is in Australia. It is, but the capital of Australia is Canberra.
Yeah, it says here on the
Which-
paper too. There is an image here.
Okay. Yeah. So the multi-step reasoning example there is. Can you look at it again, Victor?
Yeah, you can see
oh.
it here on the
What is the capital of the country where Sydney is located? So basically, the model here, it has to generalize in the sense that it has to use the fact that capital of Australia is Canberra and that where Sydney is located is Australia. So what is the capital of the country where Sydney is located? It should answer Canberra.
Yeah, and we know some things about how this kind of question is answered on language models, because there is some anthropic papers that have shown things related to this, where seems like, or at least some vague notion from attribution graphs and all that, where there seems that there is some mechanism where the model can get can store facts about count, like they didn't make up this kind of data set. There's previous research with this kind of question, like the anthropic paper.
Yeah.
Okay.
But one question I have: what model are they fine-tuning that doesn't know the capital of Australia?
Maybe this is an example, and they are. We'll get to the examples. Maybe this is an example for clarity, but the actual, what I will do is make the actual facts made up. You know, like maybe some random compilation of letters.
That's what I'm doing in my experiments. Yeah, basically.
Can I ask another question?
Yeah.
Go ahead. Ask us.
Yeah. So I mean, I guess we're still in the introduction, so maybe I should be more fair by actually reading. But they mentioned that they're introducing self-patching, and it's a variant of activation patching. So, do you have any idea what self-patching is and what activation patching is?
I know what activation patching
have no idea
is.
so far.
I don't know what self-patching is because I haven't read the paper and I introducing it here. Okay, I can explain activation patching if you want, in case other people don't do it. So activation patching is when you, I mean, they kind of explain it here, which copies the hidden layer presentation of an anchor position. So basically, you take the you have some example, right, when you ask a question to a model or something, and you take some activations from the model and you replace them by the activations in another from the same model in another prompt. Like maybe you want to figure out how to the model does some kind of math operation, and you replace some number or some digit, and you try replacing the activations in a prompt with a number change with the normal prompt, and you see in which places of the model that changes the answer, or like what different effects it has. And there is a bunch of things you can figure out about the model internal mechanisms based on that.
So you try and figure out like what like activation patterns kind of relate to some general operation or something like that.
Yeah, or like what the effects of different activations patterns are. By like you just take the activations from some example and replace them on different places by some other example with some hypothesis of what matters. Like if you have some hypothesis that in some layer, like that there is some layer tracks some whether the number is I don't know, modulo 8 or something, you should be able to patch on that place the activations from some other question where the other number has the same modulo and it should give the same result and it should give different results if it's a different one, that kind of thing. It's just a very general tool that you can use in a
Okay.
bunch of ways.
Yeah, I got it.
And that is the division patching is the brute force way to do it, where you just try different all the combinations or the simple combination or whatever on different parts. In practice, people use more efficient ways like attribution patching, which is just a gradient-based approximation of that. But yeah, it's basically that. And this self-patching, we'll have to read the paper because no idea what they're doing. And how different it really is from actually doing the normal activation patching. But let's see. But yeah, it's worth to ask questions better than if it's just me just reading the paper. And if we spend too much time, I'll just go back to reading the paper at some point. So then feel free to ask as much questions. Otherwise,
yeah, the self-patching. Yeah, the self-patching seems to move the activation from one layer to another. Okay.
With all these scanning layers and cross fine-tuning,
I think JSpace could help a lot for localizing which layers have what representations, I think.
I'm not sure how good JSpace is, but we'll see.
Yeah, or something similar.
Yeah, something similar. Like I feel like we probably need, like, maybe in a few months we'll have some better, like that we already have the R length. There's probably better small tricks that people can come up with to improve on the J lens.
Yeah.
I think that already the J lens already improving on things like the Logit lens. I feel like maybe it will help just by making people think more about the question and that kind of thing, and the people will find better methods. Even they think they're not looking that much like the AJ lens. Okay.
Yeah.
Thoroughly scanning layers in LLMs. Self-patching gets a time-evolving, fine-graining spatial map of the permeation of knowledge. I don't know how it does that. Okay. Identifying which layers and positions contain representations that can unlock the correct answer when rotating into an appropriate position.
Does it mean
yeah,
that
we'll have to
experiments
read
are
the
going
actual method,
cross-domain?
but it's weird. Like, so it says saying it's identifying which layers and positions have. I mean, so we'll see on the actual method, but I'm curious what's different from this from doing gradient patching with the correct position. You know.
Which part are you commenting on?
Oh well, no, because you can do gradient patching. No, you don't do gradient patching that way. But
also, I see they talk about chain of thought there in that paragraph. Okay, just means they try different domains of X. Yeah, so their gains of their method exceed baselines like chain of thought and generic perturbation controls.
Yeah, I'm a bit confused by this. We'll see the explanation because so you can when you do activation patching, you're usually plotting the effect on some some metric of the patching, and I don't know. We'll see what the explanation of the method is, but it sounds to me like this self-patching is just gradient patching up. So it's just not gradient patching. It's just activation patching applied to some specific application, maybe. But maybe they are doing something different. But I don't know.
Isn't the self-patching different in the sense that you transport one representation from layer, transport the representation from some layer to another layer?
Okay, yeah. Okay, so they are changing layers. I guess you can tell
I
that a
think.
new technique. I feel like there is a bunch of things I've done with patching on papers that, or like on research that I just didn't call a new technique because to me it's all activation patching. But okay.
Yeah.
I
Here's
guess
the image. If you wanna look at the diagram, there is a self-patching. Same entity from another layer. Layer
Yeah.
I to layer
I guess I
J.
should go in order and finish this. Go back to reading and finish this. Okay.
Yeah,
Based
while
on the
causal
observation-
tracing corrupts a run, patch scope into precedent state by decoding into natural language and self-patching. Test the effect position by swapping its internal representation across layers and context. That's what different in self-patching.
Based on the observation, we propose the knowledge circuit misalignment hypothesis regarding the knowing. Oh, it's self-patching just because they're patching instead of from a different prompt, like for the same prompt but on a different part of the model.
Yeah.
Okay,
Test
that
the
makes sense.
effect position by swapping its internal representations across layers and context. So also different prompts, I guess. Context means prompts,
Okay,
I
that's
guess.
been fine to call self-patching, I guess. Based on the survey, they
Yeah.
propose the knowledge circuit misalignment hypothesis regarding the knowing using gap. Self-patching reveals that after memorization saturates, injected information is retrievable from certain layers. Wait. Yeah. So.
But could you completely localize it by corrupting the whole model? And then seeing what is the
I
smallest
haven't tried that.
amount
If
of
it
non-corrupted
does
model.
work, if you take the thing from some part of the model and you move it, and that works, that's kind of surprising to me. Or a bit, not that much, but it's very interesting to me. So, but we'll see what the actual results are.
So what did you understand that self-patching is that's different to what it was before?
Okay, so I think self-patching is they instead of the normally activation patching, you take some prompt and you take another prompt and you patch the activations from one prompt into the other on the same place. I think here it's on the same prompt, like from some layer to a later layer.
How could you compare these things at different layers, though?
You just switch the vectors, or I'm not sure. What was the question
Sorry,
exactly?
can you repeat the question?
I guess I just wonder, in what way would you think that there's like any meaning comparing activation patterns across layers? Because isn't the activation pattern a function of all of the layers simultaneously? Maybe this is not an intelligent question.
Core of the layer?
Different layers have different activations, right? Like the activation is just the and
I guess I understand. So I mean, if I just think of some deep network, I can imagine different activation patterns layer by layer. But if I was thinking of a ReLU network, for example, I would just think of the final distribution of activation patterns as the one that the network has access to, and the intermediate activation patterns I probably wouldn't attribute meaning to. Well, maybe there is some reason why I should.
Mech Interp tries to find quote-unquote meaning, which is defined as being able to causally intervene them. So like there are methods for looking at the intermediate activations, like the JSpace is one famous example right now, which can find that actually on layer 5 or something, if you take the activation, you can interpret it as, I don't know, Mars or something. Then you switch it for Earth, and then the model will reason about Earth in the last other layers. Like Mech Interp is trying to find the black box, make it more white box. Yeah.
Like I don't know. I mean, if you have obviously the model is doing something in the intermediate layer, right? Like you have a model and it has different activations on the different layers, and like it does some computations in those activations, and there is some interesting algorithms there we want to understand. And you know, if it gets the correct answer in the last layer, it's because it did something on the median layers, and you can often figure
I
things
see.
out and patch
So
things, and I don't know, find that different parts of the activations mean different things, and they have some coherent meaning when you intervene on them and you change them, and turns out there is some vector that makes the model talk more about the Golden Gate Bridge or whatever.
okay, I see. I see. So you're sort of interpreting the prior layers as doing some specific operation, and then the final layers as doing another operation given the previous layers. So you might want to know the correlation between these two things. And so it can be meaningful to talk about activation patterns across layers.
Yeah, not just correlation, but also how they causally influence the last layer.
Okay. Cool.
If you
I got
can
it.
test with ablations.
Yeah, like you should also. Yeah, I think that the thing here is also whether if you take the activations in some layer and you put it in a different layers, kind of if the representation has the same meaning on different layers or something, or different meaning, but like it has some coherent effect. I feel like it has interesting results whether this works or not. This kind of self-patching. I think there are reasons to expect that this will work better, especially on transformers that have skip connections.
Yeah.
That
The
since
resonance,
there is skip connections, it makes sense for the model to not have like completely different representations on each layer, and more like have variables that multiple layers read and that kind of thing.
Yeah,
This
I
makes me also
agree.
think. Oh, go ahead. Yeah, like maybe this. So yeah, I haven't seen the empirical results yet in this paper, but this makes me think if they like switch activations from layer 1 to layer I to layer J, this seems to, I don't know how exactly they do it, but if they just copy the vector basically, or switch the vector basically, this makes me wonder. This seems to assume that the coordinates and the representation geometry is same across layers, which is something that JLens is showing is not necessarily the case. So they try to fix it with the Jacobian.
Yeah,
I wonder
think
if you
there
could
are
use the Jacobian here
some-
to make it even better.
Yeah, I think there are some. Like I say, I think there is some pressure towards that with the skip connections, but yeah, it's not necessarily
Yeah.
perfectly like that. That's some. There are other reasons why you
Yeah.
might expect that there are some representations that are different. Especially in this case, where I will be a bit surprised if the paper shows it works. In that, it seems like interesting if there is this vector, like it's actually the same vector, and if it was on a different place, it will get the correct answer.
Actually,
But it's not on the correct layer or something. And that's mildly surprising.
maybe I didn't fully understand. Are you saying with the self-patching thing, what they do is, let's say they isolate some layer L1, and then they find the activation pattern on some input for that layer, and then they go to the different later layer L2, and they just replace that activation pattern in that layer and see what happens? So I can see one situation in which this makes sense. If you have, like, let's say flow matching, for example, then you just have some linear interpolant for flow matching, you can think of like if you just take the activation pattern and then you just like put it to a different place for something like a skip connection network, then you kind of are just free streaming like a sample from one layer all the way to the target. So maybe that would be a situation where something like that would be sensible.
Okay, I know what flow matching is, but I'm not sure how exactly you connected it.
Yeah, I don't think I explained that well. I'll try and think of a different example. So if you think of
are you talking about diffusion LMs, by the way?
Not necessarily. I'm kind of more just talking about ResNets. So,
Okay. Do
like,
people use
how
flow
about
matching
this?
on ResNets?
Sorry?
Do people use flow matching on just ResNets?
So you wouldn't have to use flow matching, but like I think I'm getting kind of sidetracked here, but like if you think of a deep ResNet and you write down like the equation relating the different layers to each layer, you just get the same thing as a flow model. As in like the
really?
layer derivative between
Wait,
two
what?
layers is equal to some velocity.
Isn't ResNet basically just like doing residual stream stuff?
Exactly.
How is it equivalent to flow matching? Do you mean flow matching from diffusion, like generalization of diffusion, like
Right. So
learning vector
I
field?
misspoke. I
How
shouldn't
is it
say
the
flow
same?
matching. Okay. So
Oh.
like it'd be better if I could write something down. But if you write like, I don't know, XL plus 1 is equal to XL plus some F, like activation of XL at L. I don't know. I'm like speaking math. Maybe that's not easy to follow. Should I write it down somewhere?
You can write down if you want. Did you try to describe? Did you try to like residual connection of like?
Yeah, like if you just
That
stare
x2
at
is
this.
fx1 plus x1.
Yes. So if you just stare at that, you move the one like XL to the other side. You can think of this as a discrete derivative. Is equal to some function of XL and L. And this is the same
Discrete derivative.
like
Are
equation.
you now trying to take a gradient, or how is it equivalent to discrete derivative?
Yeah, it's so if you think of the difference between the two layers as some kind of like a time derivative, then you so you can you get the same equation that you would for like a flow model.
Oh, I think
Yeah.
I'm starting to see it.
Oh yeah.
So you
yeah.
mean like each layer is doing like each flow step, you could say, in the vector field?
Yes.
Using the vector
Yes.
field. That is very interesting
Yeah,
connection, actually.
Oh, okay. Yeah, you can kind of think of a ResNet as like, performing some kind of flow through layers. And in
now
flow
that makes
matching,
sense
what
to
you
me.
do is, sure, yeah. And in flow matching, all you do is you make an interpolant between like an initial input and a target, and you try and train the model to follow that interpolant. With a ResNet, it just learns something on its own. You don't guide it with an interpolant. But let's say you did have these interpolants. If you wanted to compare activation patterns between layers, and like this would be a little bit like having a linear interpolant. If you would just get the same activation pattern between layers, if that makes sense. Yeah, sorry, that was such a tangent.
Because it's different step.
Yeah.
It's because it's different step in the flow.
Exactly. Exactly. Yeah.
And when you
so it's
compare it, you I guess you can just remove the shared basis or stuff like this as well. Yeah. Okay.
Yeah. Yeah. Sorry for the tangent.
That is an interesting connection. I'm not sure if it's exactly mathematically like it makes sense to me, but yeah, it makes sense to me. Though I'm not sure what can I derive in practice from this mathematical connection.
Yeah. Fair enough. Fair enough.
I at some point I wasn't paying that much attention. I was reading the paper. Sorry.
No, that's fine.
He basically
it becomes relevant.
Yeah. Well, he basically described this idea of like that you have the residual stream and each layer, each feed forward layer, each attention layer, and so on. They add more and more stuff on the residual stream, which I guess Mech Interp likes to see the residual stream as like some kind of shared scratchpad on top of which all the layers write and remove and so on, and rotate and do all sorts of geometric transformations, whatever. to like add representation, use them together, and so on in the different layers. So he basically connected it to the idea that it's like a flow. Like, you know, in when you diffuse an image, you have an image, then you change it, then you change it, then you change it. So it's like similar there. It's like a residual stream, then you change it, then you change it, then you change it. That's the mechanical connection as far as I understand.
At that point, is not everything where you have a thing and you change some parts of it in some iterations, basically describable as that.
Yeah, that's why I'm not sure what practical stuff this connection gives. It seems very abstract. Maybe because, you know.
But maybe there is some interesting mathematical thing you could do it, framing it that way. But yeah,
I think the difference from diffusion and flow matching models is that there you always have the same function, which like changes the vector at each step. While here,
doesn't that not apply there because it's different function each layer?
Say again.
Isn't it different in that it's a different function each layer?
Yeah. That is different here because each layer has a different function.
It's more like diffusion then, right? You can think.
Yes.
Then you always use the same neural network to do the diffuse step,
that's
unless there are some methods.
Yeah.
If there are not some other methods, which I'm not aware of, where they use a different network at each diffusion step.
Anyway, so no, let's wait. Let's go back to this. So
yeah, but you can at least in Mech Interp, what people usually think of it is that like the residual stream is like this shared sketchpad on top of which each layers add and change and use for computation all the various representations.
I think there's like one of the articles where it shows that I think the earlier toy model superpositions, like one of the earlier examples we could read about this. It just shows how like the attention heads read and write onto the residual stream, and how the attention heads are a lot smaller than the residual stream, so you could think of it like a read and write operation on it. And then the layered on does something else.
No, I don't think. I think it's the toy model of transformer instead.
Yeah, it's toy model transformer. That one's the better one.
Continuous fine tuning after mutation sometimes brings. Okay, so that's saying.
Oh yeah, Oh, go ahead. Yeah, I think it's in this toy model superposition instead. Yeah, I don't know. There is mathematical model transformer. Mathematical framework for transformer circuits. I think in this paper they describe what we are talking about.
Yeah. So anyway, going back to the paper, so they have this knowledge circuit misalignment hypothesis. First patching reveals that the thermalization saturates, yet the information is retrievable from certain layers.
Yeah. Maybe, Victor, you had this comment that this paper assumes, when we talked about that this paper assumes that the coordinates of the representations are the same on all layers that JSpace tries to fix, or JLens. Technically, LogitLens assumes this as well, that the coordinates of the representations are the same.
I think it assumes something worse. It assumes that they are the same as the embedding, like LogitLens.
Yeah, that an embedding can interpret them because
I think there are reasons to expect that the coordinates might be the same now. The same because when you think about the residual stream as as something that things right, and since there is skip connections, you should assume there are some variables that are the same the whole way, or they are only slightly changed. The model can have to explicitly all of the variables on all of the activation features on the previous layers are going to exist on the later layers and unless they get override by something.
Yeah, that as well. Yeah, I would expect there's a lot of pressure to not change the geometry.
Like by default, the skip connections make it so that the activations by default remain similar, and you need wait to override them explicitly.
Yeah. I would expect there's also like stuff like rotating and scaling and stuff like this, which might be sometimes useful. But yeah.
I guess I
will
expect the model to rotate something if it means something else on a later layer, you know?
Like I think we have the evidence for this in the when it's like adding months together, like when it's doing the the December plus 2 months equals January, that it's like rotating on the circle there.
A paper we can read on there is a paper about how representation of numbers is the same kind of Fourier stuff on different models. A new paper about that.
Oh, nice. More evidence for the more evidence for the Platonic representation hypothesis, or a weak version of it.
Continuous fine-tuning at memorization.
CEO probe, founder probe, mission probe. Yeah, they have a lot of examples in this paper now. I'm seeing.
Anyway, going back to this. Well, okay. So what's the circuit measurement hypothesis? Self-patching reveals that after memorization saturates, yet the information is retrievable from certain layers, but it's not reliably integrated in the computation required for multi-hop reasoning.
This might be too strong, but maybe fixing this, what this paper is trying to fix, will solve continual learning. I don't think so. I think there's more to it.
Continued fine-tuning after memorization sometimes brings this use our representation into mid-layer computation.
Yeah, it might be just part of the giant puzzle.
Also, natural gradient dependencies. What do you mean by this? I guess because it's training only on the other ones, and it doesn't generalize that way.
Well,
yeah, I'm not sure what they mean.
It fails because the presentation remains stranded after the natural gradient vanishes.
Yeah,
maybe
I can't
when you do the gradient,
what they mean by that.
Errors.
But kind of want to. No, I think it's just okay. They're talking about how after the accuracy of memorization goes up, it stops at some point. Like the accuracy of the multi-turn thing also goes up, but only a bit, and it stops going up after a bit.
Oh, chaining accuracy. So that's the multi-step reasoning.
There is something like the Grokking paper here that, like it doesn't even after because I find something they are only training on the blue thing. So
maybe if they cranked up layer norm and learning rate, it would shoot up to 100%.
Yeah,
like
maybe it's true. I think this is the question of whether it will go up more here, and maybe not.
I feel like the memorization versus chaining might be determined based on the specific type of task or question.
Yeah, I expect that to be the case as well.
Yeah, because they didn't really. Did they specify there what task or question they're using for that? Because, for example, like, I feel like
they have a lot of examples.
Do they give examples of what they trained on for this?
Yeah, there's a lot of examples across different domains in the whole paper.
No. But they should label it based on category. Even if they do a lot of examples.
Okay. Yeah, they say cross domain. I think they divide it into different domains.
Yeah, but they should maybe measure the knowledge using gap for different domains, because I feel like some domains, like for example, like he taught a model like some new math theorem that's like very niche and won't be used anywhere else, like unless you're asking about that math theorem. they're not going to really use it.
Yeah, like I think here they just do extremely simple facts from different domains. But I see what you mean. Math will be much harder than
I also think that in this kind of
capitals
thing,
of cities.
like when you make the model, when you scale the model and train them more, like how much it generalizes from this training on this to this increases. At least that's my experience when even training in very toy models on the modular multiplication thing. If you remember, Bernie, like the thing where I was doing with aliases and all that, which is kind of analogous.
Yeah. And what was your exact connection to this paper here?
Oh, it's the same kind of thing when you train it on a thing and it generalizes to another, but only a bit.
Ah, okay.
In that case, the reason is that it's kind of reusing some circuits from one kind of question to another, and so when the gradients, like in that case, it's a one layer toy model, so it's just the embeddings that, like the training in one question, like the way to solve it is make it more like the is since it's reusing some of the directions that the other thing uses, but not all of them. So it's the resulting vector is kind of aligned with the other question, but not completely, and they just have different norms. So yes, part of it.
I see.
Well, actually, that's maybe I should publish my other thing, and because I know this is something for that. Maybe I kind of want to check if on the effect of self-patching on just instead of self-patching doing on the same layer, but increasing the norm of the activations or something. Or I guess it would be better to try to separate what the activations for the specific thing is. Like you take the average of a bunch of questions about Sydney and a bunch of questions about something else, and you try to get the average Sydney activations, and you just ramp that up and see if that works, because I have an alternative hypothesis here, but yeah, let me read the paper first. I'll think about that.
Adding Sydney steering vector.
Yeah, something like that. In that, I guess if they are doing self-patching, then maybe it's no. I guess that doesn't. It's not the thing I was thinking, because I was wondering if we were doing something like steering, then my thing would make sense. But here I'm guessing they just patch with the same, the same activations. Still could be happening accidentally. I need to think more about this, but like have some vague idea of like maybe it's just that the training on one thing doesn't completely. No, never mind. Let me read the paper. I don't think the thing I was thinking makes complete sense. I need to think more about it.
I've got another, like, maybe dumb question. What is a headroom?
Where do you mean?
They use the word headroom. Oracle headroom. I guess this is not really formal word.
I feel like that might be their own jargon for that.
I think they are comparing to some Oracle thing baseline where they have the answer in some way. We'll get to that later, I guess. We should read a bit more of the paper, I think.
Okay.
I've been kind of being stuck a bit here. And, yeah. Okay. Let me continue.
I think by that they mean like Oracle headroom, as in like the space where you can still improve or something.
Yeah, there's probably something like they have some Oracle and how like comparing to the Oracle based. If you had the Oracle, how much you could improve
ground truth data set
with the perfect accuracy or something. I don't know. We'll see what the baseline is.
I think it's just the I think it's just the baseline data set of correct answers to everything.
So they are
But
claiming that. So their model they're claiming, as I understand, is there are some. The hypothesis of the paper is so they have this gap, and they are claiming that when you train some of the representations, like there is some representations on some layers. I will guess later layers, but no idea. Maybe it's the early layers, but there are some layers where the model you see the representations when the model has these questions, can answer the blue kind of question, but not the purple question. And as the purple questions develop, there are some middle layers where that seem to be related to reasoning, and this is probably maybe this interest will be interesting to look at that with the Yalens, but whatever. That the model starts getting the same representations on the layers. Although I wonder if it's not, instead of the same representation, just some other representation that just, since it's based on the first one, it's like some slight rotation of some small change from the other, and it just happens that when you patch, you also activate the other mechanism a bit. But yeah. It fails because representations remain stranded. Yeah. So, and when you train it, the model sometimes starts having the representation in that representation on that middle layer. But this suggests that the capability to generalize injected knowledge can be activated artificially. So, like, I guess this is about if you imagine that the model can answer Australia has capital Canberra, maybe you can maybe the model cannot do this in context, sorry, in a single forward pass of like doing the 2 steps, but I don't know. I'm thinking about this. Maybe what you are doing by moving the representation is kind of short circuiting this second mechanism. Like if you're just taking the Australia token, and it's just similar enough in both embeddings that on the middle representations that if you put this, it's actually using the same mechanism as it would do to answer this first kind of question. And it's outputting Australia. I kind of will want to see like what happens with this method on 3-step questions. Although models are much worse than those. But yeah, 3-step questions. And if you replace the like the first one, if that works. Problem is, yeah, if you want the models to do 3-step questions, you probably need bigger models, though. So, I don't know.
Memorization users create tasks. Yeah, also they just added the activations. The knowledge editing for in their own paper edits whole weights. I wonder if you could combine with knowledge editing as well.
Also seems.
I like the idea they
do
try
have
combining 2 memorization tasks to call it a generalization task. However, I feel like an example of a generalization task would probably be like learning syntax and then applying the syntax, maybe. like this one is just like A, B, B, C, A equals C.
Yeah.
Instead of like,
No, I
I
know
know
what I
1
mean.
plus
It's
1 is
like,
not 2, so I use 2.
Very weak. Yeah.
I use that 1 plus 1 equals 2 to solve the problem.
yeah, I think
I-
that's
I feel like the generalization task could be like problem solving. This one feels more like A equals B, B equals C. Model could say A equals C.
yeah.
I agree.
That's the Sorry, were you going to say something?
So I say like the generalization task, their definition and my definition is kind of different.
I guess you could
this
falsify
feels more
this
like
by
this feels like another version of memorization, but more like does the model learn the transitive property?
yeah, maybe you could
I
test
think
this by
this
ablating
works,
B.
though. I think this works by like the model already knows the transitive property, right? It is not learning it here. It's already being fine-tuned. It's different on my example with the modular multiplication because there the model is trying from scratch and I need to learn on a first thing where I train it to learn like the transitive property of at least of the data set. So and then it generalizes that way. And yeah, I was trying to understand that. I never finished that. I need to go back to that. But yeah.
I feel like it would almost be more informative to train this model not in like English tokens, but just see if it can learn the transitive property or something. Like in a much smaller controlled context.
Yeah, I guess that could be tested as well.
I mean, that's kind of what I did with not this model, but like a small model on numbers with the modular multiplication, and that works. Like it doesn't work great, but it works. And though I figured out the mechanism there, and it seems like kind of hacky and not something that you will expect to generalize to other things. Instead, that it in the sense that the more general mechanism is something like the model learns from general machinery that it just learns to reuse representations from some kind of question to the other, such that it will have seen interesting questions like this, and the easier way for the great extent to learn to answer them is by using the representation of Sydney located in Australia. That have some general where this city is located representation, and then when you train on new examples of what is the like you train on text like Sydney is located in whatever, it's easier for the model to learn that new fact by updating the general knowledge storage or whatever. But it's more complicated on that because it seems here it's but there are multiple layers, and in some layer it's not always moves to the correct layer and all that. But yeah,
it sounds like they're trying to make a claim about the mechanism which which makes this happen. And I guess they're claiming it has something to do with the self-patching thing, right?
yeah. So or no, they're using self-patching to show their claim is that that there some layers where there's some mid layer in the middle layer there is some computations that do this generalization, and that having the correct vector there for Sydney or whatever is what makes that work, and training it sometimes make the vector get there and sometimes doesn't. I think there is a bunch of ways that this could not be true with the results. I kind of would want to see some things, but yeah. And
I sorry.
Spatial misalignment of knowledge storage and reasoning circuits. They say spatial misalignment.
yeah, but then I think they just mean they are on different layers.
Fine-tuning encodes new facts in easy-to-fit storage states for memorization, often early or very late layers that support direct recall, but are not reliably routed into the effective positions
by the way. Like with multiple
that are causally required for multi-step reasoning. Say again?
They have multiple. They have some tasks with multiple steps.
Yeah.
By the way, I like or different shapes of the graph of facts. There's not like A implies B implies C. It's like sometimes there's some noise and some facts that imply one. There's probably a bunch of more. Kind of going to going back to the paper and looking a bit more. So okay, data set.
Yeah, I just skipped to the method at this point. Too much fluff everywhere. Method is the 5. I wanna see the math.
I'm kind of skimming the rest of things to see if there's something interesting. Yeah, I feel like I spent a lot of time on the first part. I should go read the rest. Supporting fact triplet. Per fact. Okay, so it's like so it's 3 facts. I guess that makes sense.
This makes me wonder. So fine-tuning encodes new facts in error fit for memorization. Okay, so it doesn't get like recalled in the residual stream. All right, using the weights. Okay. Using their hypothesis, which they try to test.
I think what I'm confused about is what the self-patching thing, like what they see and what that's supposed to mean.
Okay, so let's go to the. I was looking at this. Let's go to the self-patching thing. Yeah, causal tracing is the typical thing when you.
How does patch scope works exactly? Is it like JLens? Is it like LogitLens?
I vaguely remember what was patch scope. I think
It looks like LogitLens. How does patch scope compare to LogitLens? Oh, it uses probes. It doesn't look like LogitLens. It's probe from hidden state to words.
How did you get worse? I feel like I read that paper, but I don't remember right now.
Yeah, if you look at the at this diagram here of patch scope, on top you have CO probe, founder probe, mission probe. So you learn probes. Okay, patch scope. Insert an intermediate representation into another probe context and let the model interpret it.
I have an idea. Remind me later, Brunito. I have an idea that you could try with your OpenAI crates and agents that I just had. But
yeah, you can write it into a prompt.
Remind me to tell you all that later.
Yeah.
Okay, so self-patching. Let them be the layer transformer and let. So this is just explaining.
Yeah,
with
patch
a lot
slope
of
works
stuff.
completely differently. Oh, you see math and you skipped it? I see math and I started reading it.
I mean, on the self-patching is just the same thing, but explaining with more math.
Okay. I'll check it anyway. Maybe there might be some important nuance.
That's true. Yeah. Yeah, I guess this also feels like it's interesting how this reasoning mechanism works, and it's kind of poking at it in a bit very low resolution way, but it's okay.
Ooh.
Uh,
Ooh, I see beautiful pictures.
okay, so
Memorized but not generalized. Ooh, accuracy from 0 to 1. Do they have a example of successful generalization? That looks like rocking graph a bit. Well, not really, because it's still memorized. Okay, no, it's not. You need the memorization. It would be funny if the memorization started dying and you only had generalization. But yeah, that would be like rocking, but
what is
that would
this
be terrible.
graph? I find the process. Cells measure whether patching the head empty representation from one layer to the source layer to the target layer increases generalization accuracy.
Oh, so they like permute and try like basically do brute force search.
Yeah, with red indicating full recovery. I mean, you call also this is probably not super efficient. You can also do it by doing gradients instead, like gradient patching. Like you can do gradient self patching too. It's the same as doing the normal patching.
Does it exist? If not, that sounds like a paper to do.
I feel like you could do the like take this paper and do ask ChatGPT to do the gradient version. It will be or do it yourself, and it will be not that many lines of code. There's probably something with which layers you pick and all that makes it annoying, but yeah. Okay, so red in full recovery, blue no effect, and white for partial.
How big is their models? Oh yeah, Qwen 1B. Patch.
I think
With,
also
without.
1B is just probably not that good at chains of
So
reasoning.
yeah, well, not like if you look at the graph right under this what you're reading, it's not that different between the differently sized models. It doesn't make that much difference. Yeah, here. I think that's the data sets, the Stark Prime, Stark Mach.
Yeah, so okay, let me first try to figure out this one. Okay, so this is you. Okay, so patching the head ending representation increases.
And this is a very easily verifiable task because you have the exact oracle. So technically, you can use Codex to try to do this paper.
Okay, so
because,
you take this and you take something from this layer and to patch it into the other layer and see if that increases the memorization accuracy, right? Memorization accuracy, sorry. So
yeah,
and this is as you train. At the start, it doesn't because the model doesn't even have the correct representations. But interesting, at some point, it works from some layers. In fact, from layer 0 to this is the what's source and what's target?
I'm a bit confused with the
Target is here.
with the what is exactly the colors? Like blue is nothing.
Okay,
white
blue
is memorization.
No, blue is it doesn't work. Red is works, and the white is on the video.
I thought blue was the memorization task, and red was the chaining accuracy.
Here is just the accuracy on the.
Oh yeah, I see here.
Like, okay, blue and red it's a kind of confusing because on this graph, blue and red are memorization accuracy and chaining accuracy. This is kind of a chart crime in that on this, the colors mean on different things on different parts of this graph. Here it means
that confused me.
Accuracy, and on this the colors are they are the chaining accuracy after patching. And blue is bad and red is good. Like it's a thing from 0 to blue is 0 and red is whatever there is called accuracy. I don't know. So it seems like as you train the model, starts the chaining accuracy doesn't seem to go up on this example. But there's working on more layers for some reason. Like it's also for the early layers. So I'm wondering if this on here is actually the effect from the thing I was thinking earlier of okay, so okay, so you have this question, right? Of what is the capital of the country where Sydney is located, right?
Mm-hmm.
At least on this example, it seems to me that what you are doing is when patching, if you patch for layer 0, you are doing something like you are putting here, you are patching the token, the embedding for Australia. So you are confusing the model into thinking what is the capital of Australia, and it can answer that question because it was trained on it. And I think there are some examples that you could use to separate that from other kind of reasons, but I will I need to see them. But I guess there is another case where it did generalize, right? And in that case, it seems like it works from a lot more layers. So
I'm a bit confused here. Yeah, like how is the last square almost fully orange?
Where?
What is
the last square in
here?
Like how?
Oh,
does it?
Okay, I think it's a dumb thing of their method. So the model already has good accuracy, so it's.
I noticed that like the memorize
by default high.
Examples like why are there so many of these graphs? All of them show layer. They're showing it between the different epochs. I see.
Okay, but this increase, so it seems like it does. It's interesting that it increases in most layers. Most of the things that you do increase accuracy, like most patching.
That is so confusing to me.
Yeah, I don't understand why.
Why would swapping random layers like this? Like I wanna see the baseline. No swapping. I guess no swapping is if you replace L1 with L1 So that's the diagonal. That's no sweeping.
I find it interesting. It goes from like activating like everywhere, memorization activating across every layer and like target layer, like across every target layer on you see at the top, like it all blue. And then as the training dynamics go on, like there's
It's a bit confusing because are they plotting the diagonal? It seems here that they're plotting the diagonal, and like it should have no effect, right? So what?
Yeah. So what is the difference between target layer and layer on the y-axis? What's the
Maybe
difference?
no effect with
Okay, so
respect to
they are
the
passing
beginning.
from the source layer to the target layer. Right, so this is the source layer. So this means that they are patching layer 0 into layer 0, and for reasons from the half effect, that seems like it's just some fail in the graph or something. Like, it doesn't make sense. It should have 0 effect unless they mess something up badly.
Yeah.
So I don't trust this graph anymore.
Yeah,
This
I
is so
think
weird.
I think I have a lot of confusion, so I hope you don't mind answering all my questions.
Yeah, why not?
So yeah, so I apologize in advance. So what's happening here? When you say that they're patching a source layer to a target layer, are they basically saying we're starting the model from that layer onwards for this particular sample? Like what exactly are they doing? Yeah, I guess my question is what does this graph mean?
Okay, so as I understand it, you take the model, right? You you run a forward pass on the model, right?
Mm-hmm.
You store the activations from that forward pass, and you run another forward pass. But when you get to some specific layer, you replace the activation from on that layer from the activation on the other layer from the previous for the original clean forward pass, and
Okay.
you continue running the model from there. Like there is some libraries for that, like Transformer Lens and Insight that people use for interpretability.
And it's a feed-forward network. Because I mean, correct me if I'm wrong, but if you just isolate a layer, feed in a new activation pattern, and then run from that point, surely everything before that layer is irrelevant.
I mean, yes. Well,
so it's kind of like you just truncate the model.
I mean, it's not irrelevant necessarily in that
it's path dependent.
Is there yeah, okay, maybe I'm confused. It's a feed forward network, right? So there's no weight sharing between layers. So if you just isolate a layer and then input an activation pattern, the later layers only know about the prior layers based on like the single previous layer. So if you just
you also have a residual stream
activation pattern. Oh, sorry. Does this not count as part of the activation pattern? Is the residual stream considered something different?
No. No. That's part of the activation.
That's where activations are. Yeah.
Yeah, no,
yeah,
but
I think they
can't be.
I'm not exactly sure. Do they switch residual streams activations or just inputs and outputs of the?
You can see over there at the 5.2, they say they perform layer-to-layer patching. I'm assuming it's probably the end results for the residual stream because that's
yeah, I think it's I think so going back to the previous thing. So there is skip connections, so it's not necessarily the case that if you patch on any point of a transformer, I think it's a transformer. You patch any point of the transformer, it will you can ignore the previous layers because
I see.
you could, if you do it between skip connections, you could get something from the previous one. But I think they usually do this kind of thing after the skip connection, like just what people usually call the residual stream, like the activations on the point after the skip connection.
That's interesting. Okay.
So then it should be the same. But I mean, all of the things after the other layer should be the same. Like should be different now, because you changed the activations on that layer.
In a way, yeah. In a way, it's kind of like you add a
think-
perturbation to, like, you have some model and it does its thing, and you just add some perturbation to the weights at some layer, and then see how that perturbation propagates, I guess.
Yeah. Yeah. So this thing, here they're doing a bigger thing because they're. I understand. Maybe they are. Are they actually? Yeah, there's the. I'm not sure
think
if
the
they are
diagonal-
replacing the whole weights or they are replacing just some part of the weights.
Like just
actually.
activations. They are replacing
Yeah,
just
but are
activations.
they replacing the whole activation? Sorry, are they? I said weights. I was mean activation. Yeah, are they replacing the whole activations or only like some heads or something?
I think they are just replacing the whole RSG stream. I would expect that. I think. I'm not sure.
That's a big. Yeah, that's a big intervention. I'm surprised it doesn't break the model more often.
So, okay, sorry, you can carry on.
So what I'm trying to say, a lot of other papers that do this kind of activation patching are just patching some attention head or some sparse of the encoder feature or something. They're patching some small part of the activation and see how that affects.
Okay, they are not patching the whole RSG stream.
Okay, that makes more sense. What are they patching?
So you can interpret this.
They scan source layer, target layer pairs. I have to look at the math. Also, by the way, there's a quote that in successful cases, the red region covers the diagonal line, which means the natural emergence of generalization from fine-tuning. So I expect in this graph, the diagonal. I think it's an absolute accuracy relative to the very beginning.
So the diagonal is like the baseline.
Yeah,
right.
Diagonal is a baseline.
Okay, that makes sense. Kind of a confusing way to do the plot, but okay.
Yeah, it is.
And are they? So this operation where they I hope I'm not getting
anchor token, sketch source state, hidden layer, replace.
You need to look at this graph just to understand it. Like you see Pepper, my bad. You see the 5.2 at the top, it just says the layer to layer self-patching, and then see the bottom part of the red and blue saying like no change. I'm curious on what the gray color means, because they didn't say what gray means. Because blue meant no change, and red meant like the memorization 16.
White for partial gain here, at least on this one. You mean this?
What does it say white?
You mean
white
the slightly blue? I
no,
think it's
blue
a gradient.
means no effect. Just blue in general means no effect from this graph. I guess white means partial effect. I wonder what they consider.
I think it's just a gradient from with red, yellow, and blue, and that's it.
Yeah, I think it's a gradient.
But
the red doesn't have a gradient, which is weird. While the blue has a gradient.
So it's kind of suspicious that this graph is being so red, especially if they replace the whole thing. But yeah, like I mean.
But it kind of makes more sense, right? The more the model is trained, of course, the more patching would affect the model. Like it's more like the trained, every single layer has
random layers always increases the accuracy. Like what?
Just be this.
No, this is absolute. This is absolute accuracy. So like diagonal.
But I thought the things that were not diagonal were relative. So like where increases.
I think not. I think it's all absolute. Otherwise,
okay. Then this is a bad graph. They should have just plotted the difference.
So you can see in the last one, some of them break the correct answer, some of them don't. But you can see the diagonal is always red.
And not only that, it feels like passing in purpose to make it look nicer.
And when you look at the previous one, actually, if you look at the previous one, you can see how the diagonal is mostly white. while the patching.
Yeah.
No. I mean, second last.
Yeah.
No. Stay where you were. Stay where you were.
Oh. Okay.
And
here.
Yeah. You can see that the diagonal is mostly white, while the patching is it's more orange. So it seems like it's useful in this intermediate step. Yeah. So here so in the last one it mostly breaks because baseline works by default, and in the second last one you see how patching helps a bit. And here you can see it more broadly that patching the earlier layers with the it works better. So you see the square at the earlier layers. Also, why is it so distributed? That is confusing to me.
So,
I think I see the graph now more.
Sorry, we were asking.
Yeah, so just like one last dumb question on patching. Just because this is the first time I'm hearing about patching, do you like do this during training? Like you freeze the layers, pick a layer, and then transplant the activation pattern to that layer? Is this like done throughout training, and then you see if things improve?
Training, but for this one, they're doing it for inference.
You can do it at any checkpoint, doesn't matter.
Yeah, so okay, so normally people, I see more papers that do like on a model that is already trained, trying to figure out how it works. So they do patching to try to figure out something about how it works. But there are some papers on like trying to find out developmental stuff, like how the model, some mechanisms appears on the model, and I seen them do that. I think no paper comes to mind. I think it's rarer, and there is a bunch of reasons why that will work worse during training, in that the representations can change during training. You could do it. It's not usually what people do, I think.
I guess I'd imagine it sounds like a perturbation on the weights that you just sort of do systematically during training. So maybe it would make it more robust if you're like doing this process where you just shuffle around the weights every now and then. So you end up reaching a solution that's going to be less sensitive to the particular like tuning of the weights. So I guess I could imagine that could help generalization. I'm just wondering if that's what they're doing here.
No, they're not doing that here.
No.
Okay. Then
but
what role
I think
does
that
the
change weight? No weights are changed at training here. It is just normal fine tuning without anything. And self-patching is just later. Yeah.
So
there are methods to change weights, but this method itself is changing activations only.
And so why are they doing this patching at all?
Since they here in this graph they claim it improves generalization accuracy because earlier layers learn facts that are not used in later layers in some reasoning circuits, and if you patch them,
they're also
you will
trying
properly
to.
use
They have
the facts.
some hypotheses about how the model works and how this kind of generalization works, and they are trying to give evidence from it with this patching.
Okay, but they're not patching during training or anything, so the patching isn't influencing its ability to generalize, right?
No, they are patching during inferences and see if that improves generalization on inference.
Yeah.
So it's to interpret the model. I guess I'm just confused. How can this affect generalization if it doesn't interact with training?
Because
at inference you interact with activations.
So they are doing the patching on some. So basically, they are taking the model, they run a forward pass, see that it gives the wrong answer, and swapping the layers and see if, on average, when you swap the activations, that increases the accuracy.
I see. Thanks. Yeah.
Because swapping the activations changes the answer of the model. So, and if you have the correct hypothesis of what kind of swapping will get the correct answer, you will be able to increase the accuracy by always stepping on the same place or something and seeing if in most ant questions it gives you the correct answer much more often than the model by default, right?
Thanks. And so when they like say epochs here, is this like
they are
number of
training the
epochs of
model.
patching?
So,
Sorry?
No,
have
they
you
are
tried
training
training
the model.
in PyTorch before? I
So,
think the
what?
epochs. Have you tried training like the? I think they're just referring to like the PyTorch epochs.
Yeah,
Oh, yeah, yeah.
but I think he's confused.
I'm just
because-
wondering. Is this? I'm wondering what role the patching plays. I've trained a model on PyTorch.
Okay.
Is this saying like for a model that has been trained 5 epochs, when we perform patching, this is the improvement we get, or is this saying like, by epochs they're giving you a measure of how much they're patching, like they're just using the word?
No, it's training.
describe
Like
something.
they are training the model and they are patching on different checkpoints.
Yeah, there are some examples of steering the model while training it, but I don't think that's not the norm. So if they were,
Here is just
they're not doing that. So since it's not the norm, they'd probably explicitly state that.
So,
The
but it
default
sounds like
is-
what they're saying is, if you have a model that is already trained and the number of epochs is a measure of how much the model has been trained, when you perform patching, you get a certain kind of improvement. Is
Yeah.
that like?
Yes.
Yes, that is what it says.
That is
Unless
really
they would be
strange to me.
if they were.
Yeah, because like surely if you train long enough, it's already generalized, and then patching you'll expect to observe no improvement. So like what?
Here is some examples where it doesn't generalize if you train long enough. But patching still has some improvement.
You can see how
generalization.
before, when it was not trained, the patching had no effect, which kind of meant like no parts of the model were causally important for the final output, kind of.
Yeah, but the reason why it might not generalize a training might be just like still issue of learning rate and so on.
It kind of develops certain parts, like parts of it.
But at least on their setup, like the generalization, even as they train, it never reaches as much accuracy as the memorization. So there are a lot of examples where even if you train the model a lot, I mean, it's true that it might be might be like a artifact of their configuration if they have high it will work.
Also, the data set influences how well it generalizes.
But at least on their setup, the model doesn't always generalize. And on this plot, the top example is an example of some of questions. I guess in this probably an average of questions where the model doesn't generalize. You can see here because the chaining accuracy, so the chaining of the generalization task is 0, and the chain accuracy on the memorization task is basically 1 after the epoch 7. And there's these other examples where first the model memorizes, and at some point, like on the Hanqing paper, it eventually generalizes. And like they just have different plots for the both examples, and they show that the effects on patching or this self-patching on average are different on the examples where it doesn't generalize than the example where it does. They are finding some effect from patching on the non-generalization. Like there are examples where the model doesn't generalize on its own, but if you patch still has an improvement. I'm suspicious of that in that I'm wondering here they have two kind of things where it's the chaining and intersection, and I want to see the effects on chaining separate from intersection, because chaining, examples of chaining when you have some fact and this leads to another second fact, and you patch the second fact. If you think about it here, if you have what is the capital of the country where signing is located, and you patch Australia from the early layers. That's patching the embedding for Australia. So I'm guessing it's going to have an effect like replacing the country of where Sydney is located, as if it just said Australia, and then it's just what's the capital of Australia, which is the normal question.
So just erases this Sydney thing, and so it doesn't confuse it.
Yeah, I don't know, but I will have the hypothesis that that's what's going on here. They claim it's something else, but I'm not convinced from this.
Yeah. Also, on what you said, are you thinking that then, I guess, what is this, figure 4? It's like the middle epochs from like about 10 to 20 that is interesting. Where you start to get some generalization from patching in the region where we believe the model is memorized but not generalized. So
I don't know. I think there's a bunch of things here. I kind of want to look a bit more at the. I was looking at the. I was confused earlier. I kind of want to look at this. Okay, so let's see. Also, if people want me to look at some other parts of paper, I can also do that. I was just personally, I'm curious about this a lot right now because.
Yeah. Also, they're replacing the residual stream state to correct again myself.
Okay, so they are representing
the equations. They have hidden layer at layer S for token S. So that should be the whole residual stream as far as I know.
Yeah, it's surprised that doesn't break the model more often. But okay.
Yeah, I'm also actually surprised about that.
But I guess maybe models are just robust to swapping layers, and in this case it just has the same, the model had the correct answer and some swaps break it, but it doesn't matter much. It's probably related to the model has skip connections. Most layers have similar activations, and if you like, maybe if there was a model question that requires some more complicated reasoning or whatever, the model would need multiple layers and it will break more. But as long as you swap layers that don't matter, it probably doesn't break the model. So that's probably what you're seeing here. What happens on the early layer? Okay, so first, the model doesn't know the correct answer, so the base leg is bad, so it's just not going to... It is part of the memorization, so it doesn't even know whether Sydney... Well, it probably knows the Sydney one, but it probably doesn't know the whatever the artificial ones they're using for the... I don't know. That's another thing I'm confused about how do they check that the model doesn't already know the answer for some questions and what questions they use exactly, but okay. So then there is this thing where it memorize and it's kind of where it's starting to memorize and it's not doing generalization, and then it looks more like this thing, and this is where I'm suspecting that it's just like rewriting the second part by what the second question is, and that's why it's on the early layers.
On your first question, isn't the diagonal the control then? Like, because the diagonal one would be
is the control apparently.
If the diagonal's blue, then. So if the diagonal's blue and everything else and other things are red, then that indicates that the model doesn't just already know the thing, but the patching's actually having an effect, right?
Yes.
Yeah, so it's kind of these early ones that are interesting.
Yeah, I think that it's also here it has a similar effect to this, and it's probably related to the thing I'm saying that this is like on the layer 0 replacing, it's like replacing the text by the middle step thing by Australia or whatever.
Yeah, and that's maybe why the red part's in like sort of the top part of it. Like, maybe the explanation.
Okay, so this is replacing 25 by 0. So
Like
okay,
the
it's
fact
probably
how it seems. Yeah. 25. Yeah, I think so. Like the fact how
I think this is
how
might
it
be the
slowly
same
emerges.
effect, but just because later layers are tied to, like, I have similar representations to the embeddings. Like the embedding for Australia is probably similar to the embedding for Australia, and yeah, I will guess it's something like that. I don't think they have tied embeddings, but like there is probably some things. The Australia on the input increases the probability that Australia will show up on the output is probably worth to align them a bit. So by default, Australia increases the probability of output in Australia or whatever, or therefore most of the tokens. Unless there is, some token on the prompt that makes it less likely repeating on the output. But yeah.
Yeah, I really wonder what would happen if they just didn't replace the whole residual stream, but the output of the attention or MLP.
You could also try finding with a bunch of questions, finding the representation for whatever, Australia or whatever, and try to patch only that. But yeah. Okay, what else? Next thing. So it then goes increases a bit, kind of the same pattern. Starts working on the middle layers at some point. Here it's interesting because it has some accuracy, but it's still better when you swap it by this. Increasing here, it's interesting that it's white, so it still increases. We don't know. This could be not that much change. They didn't put a legend or anything on the. It's not. We don't know how much the increasing accuracy it is. Maybe it's not very big. Maybe they did some tricks to make it look more nice, where they tried a bunch of times and didn't pick the experiments that look better. But yeah, still interesting, I guess. So here it's when the model starts generalizing, starts working, like swapping starts improving the performance in a lot of the, if you swap, but only if you swap, interestingly, the early into the early layers.
I think it's actually worse to replace the whole residual stream. It doesn't make sense to me logically, because it includes everything, the whole thing.
Yeah, that probably breaks a lot of things. It's surprising it doesn't break more things here, and it's more or less, it's only it doesn't completely break the accuracy on some samples. Hello. I would want to see. Well, let's read to. I kind of want to see comparison to some baseline and stuff. Memorization patching really helps. This is indicative that the old blue map is meh. They should have plotted the difference. That's kind of misleading, I feel. Like, red doesn't mean that it helps. It just means that it's high.
Or plot both. So we have two thoughts about expanding already. Replacing like gradients of patching and replacing outputs of A and M instead of H. I might actually do that, but after work, since I need credits for work first. So I'll see how many credits I'll have left.
Related that I can ask you to put on the thing, but yeah.
Yeah, it could also work.
Okay, so the jet facts. So memorization, shading, identity, are the most effective layer. So they are picky layers. Although I mean, patching on the most effective layer is kind of if you imagine that is random, that was random, you still will get some increase because you get to choose. Like it's actually filtering, giving some information to the method to what the correct answer is. So, so it's interesting. Also, no, seems like the model does do get better consistently out of the chaining.
Yeah.
Like it's a bit,
but just a little bit. And it's interesting how much patching seems to increase it.
I think you need really big models for it to. Okay, so to be, I think the problem here is that patching is on the best possible layer, so they get a lot of layers to, select, and the method has the. If you imagine that patching randomly increase or decrease the accuracy, you will expect this method to still get some very high numbers even if it was random. Because they get to pick the best one.
Yeah.
Okay. To be fair, they are picking the best one average over facts. Then I don't have as much of a complaint. It's not like they are picking the best per fact. So they could claim that layer happens to do the effect. Then it's more interesting. Yeah. So it's like 0. I think there's more. But I think it's curious that the intersection works that much better. The intersection is the thing where there's two facts. And
yeah.
I don't sure. But does this if you just do you need both facts and not just one of them in this case?
Yeah,
I don't know about medicine. So maybe if you only have one of these, you wouldn't pick this
this
one.
doesn't seem like. Yeah, this doesn't really seem like the translation. Or I guess it's very, very, very weak. What exposure? Wait, no. It actually, there's and, right? And, so you have to know both. Okay.
Yeah, I was wondering how much do you need to know both, and whether there is a lot of. I don't know enough about medicine or whatever to.
Yeah, I also have no idea, but I assume that it's like asking, like, I don't know, how many legs does cats and dogs have? So you have to know both cats and dogs.
No, but then you know what is for or if you already ask cats,
Well,
I think you need, for these questions to be good, you need an example where with only one of them is not enough to narrow down what the correct answer is, right? That there are, I don't know, in this case, what exposure linked to the glioma, maybe there is a lot of them, and if you add this one, do you know the only one that is for both? But it's also a problem if there is multiple answers, but there is only a few of them, so you already have a lot of probability on the correct one anyway with only one of them.
The model can just ignore the second part, yeah, I see. And still answer correctly.
So that depends on things I don't know about how they set up the dataset. But ignoring that, the intersection seems like the model is better at it. Maybe it's just because their thing is bad and is ignoring it, or maybe models are just better at AND than at multiple steps. I can see some reasons why they would be better at AND than multiple steps. Because you can do the AND in parallel, and you need multiple layers for the to the chaining one. Although you can do some steps of chaining in parallel if you need to do a big chain. You can. I have for my old paper like where they find patching graphs. It could do chaining in parallel, but that was kind of a more complicated mechanism that probably all partly worked because the model was. But I can see how you do it with attention. But yeah, you also still need more layers.
Yeah. Why do they use the complex math to define the knowing using gap? That seems... I don't know if it adds more bits of information, actually. Maybe it's like makes it more formal, I guess, yeah. Wait, do they mathematically define that or not? I wanna see the hypothesis.
Also, yeah, this might not.
Okay, they probably don't define the hypothesis mathematically.
Also, do you know, Bernie, did you read what the difference between the two datasets
yeah, I
are?
don't know. Let's check. Stark Prime is biomedical and Stark Mech is academic. Which are subset of Stark, more broad datasets.
If you don't fine-tune what the accuracy of these models on those are. Maybe they just know that it's bad.
Yes, I think this answers Rambert's question that they use two groups of knowledge, biomedical and academic.
Yeah, I would wonder, like, probably with this, like, how much the model already knew from the before the, before the training.
I was just reading over the conclusion, and I think that the point of the paper is they see it is where, like, what layers of the model the knowledge is contained and what layers the reasoning is contained. So I think it's trying to construct the argument that the knowledge is contained in the earlier and later layers, and they're trying to show that by doing this patching thing, but that the reasoning occurs in the middle layers.
This seems to be broadly. Yeah, this is not the only paper that found something similar.
Oh, okay.
I think that the reasoning being on the medial layers makes sense and is true from other papers, and I think this paper did some evidence of it. I'm not sure it's that good of evidence of the knowledge being on the early layers. I mean, it kind of has to be because otherwise it needs to get to the middle layer somehow. But
what is just
confounded by the effect of the replacing by the embedding.
Yeah, but what is just confusing to me is that they replace the whole residual stream.
That's another.
That is confusing. That just feels fundamentally wrong to me. It's like replacing the whole memory, the whole state.
I'm trying to figure out
You
what
replace all
this
the information
Oracle,
stored in there.
how Oracle here.
And I want to fix this paper with this, but I'll first see how much credits I'll have after work.
Yeah.
I wanted to experiment with how much can agent do basically reasoning RL given constraints of GPU. But yeah.
Intersection is consistent improvements on bones. I'm not sure I understand what this is, how this Oracle patching works. Systematically fine-tune on different architectures, scales, and knowledge domains, and perform some patching at convergence to measure the recoverable hit room.
Yeah, my concert is well founded according to CGP. Thank you, Mr. Siffocantic Machine. You're looking at headroom.
Yeah, do you understand this Oracle headroom thing?
Let me check. Like my prediction would be that it's just the ground truth data set, but I don't know.
No, they're doing something where they fine-tuning on a lot of different architectures and something.
Oracle self-patching.
Okay, so this is the thing I was thinking of that they could be doing earlier, I think.
I think I see the definition here.
I think it's picking the best layer with the ground truth for that answer, right?
Yeah, there's a definition here. I'm gonna Oracle and fixed self-patching. For the converged recoverable headroom results, each instance is evaluated by scanning all layer pairs on the head entity position in the generalization prompt and reporting the best performing pair as the Oracle diagnostic upper bound. It's like the maximum improvement in generalization accuracy that self-patching could recover if you were allowed to choose the best patch location for each individual example.
Yeah, that's what I was thinking. Rule, position, prompting, and perturbation artifacts.
And Oracle headroom is Oracle patched accuracy minus no patching accuracy. That's what they should have plotted. The minus.
I feel like the accuracy changes will be more significant or less significant on the less trained model, since the less trained model just straight up can't answer the question in the first place. Like the change from 0 to 5% would be a lot bigger than the change from like 90 to 100%, even though the relative percentage is different for the patching.
Can you repeat it?
I just felt based on like the previous like graph where they show like the pre-training and like the post-training, like the different stages. Or you know the blue graph, the blue-red graph?
Yeah.
Yeah, my opinion for this is like they don't say like if the red is like maybe red is like a certain like threshold for a change in percent to show like it's effective and not effective. But like
You don't show
during
how
the
much red and blue are.
but
Like they could be
but do
0.5.
the yeah but do but yeah but like 0.5 from a model that like does everything randomly versus 0.5 from a model that like each part does a specific thing is like very different. Like if each part of the model specializes and does something special and you remove part of that, of course that's going to have a difference. But before it's fine-tuned, every model part of the model kind of does everything equally. So like removing a part doesn't really
Well, I
affect
mean,
anything.
it's a pre-trained model. Like, you know, it does
Yeah,
a lot
yes,
of things. It's like Quen 1 billion or whatever. So it's been trying on the entire internet before.
Mhm.
What else? Technology assistant. Eh. Leaving.
Were there any big conclusions from like Figure 5?
Oh, wait, what? Figure 5. Figure 5?
Yeah, something.
I think it's just. Yeah, it's kind of. So here they're picking the best possible layer for different facts. So, I guess it tells us similar things to the
Yeah, the red blue.
The red blue one. It seems kind of similar. They're just picking the how often the different prompts where the best one is. So it's.
I guess it's I mean, so of course they could never be along the diagonal. But I wonder if there's any kind of interpretation. Like it kind of seems like they usually only get improvement on the left side of this plot, and you can't really have any improvement on the right side.
Yeah, I mean that makes sense because if you imagine that some mechanism for answering the question is around here.
Mm.
If you patch after it, it won't.
Yeah, then you can't
work.
do reasoning.
Yeah.
But then why can it work? Oh, and the explanation you proposed for why patching like an earlier layer to a late. Wait, what was it? You're patching an earlier layer to a later layer might get rid of some mechanism that confuses it.
Oh,
Or,
my expression it's patching an early layer into an early layer though.
Early. Oh yeah, okay. Then what is let's say on 5 in the bottom right? Like there seems to be on the bottom
I
left.
think the thing I
what
said
would be
there
the
doesn't
expression?
make sense actually. Or I think it would make more sense if patching for a later layer to an early layer confuses
Wait,
it
it's always
that way.
So it's always
Maybe
early to
it's
later
like a
and
loop.
later to earlier, but not too late.
Maybe
Yeah.
it's like a loop, and that increases generalization when you patch from later layer to early layer.
No, but that doesn't work. It only works like patching from early layer to the middle layers. So that's actually the thing they were saying on the paper. I was wrong actually.
From L10 to L0. Oh yeah, okay.
No, it's not the other way. Here is from on this thing is from 0 to 10 on 15. You know?
Oh wait, I am getting confused. The
target
left.
layer. Okay.
So what are the axes? So the y-axis is
source layer, and this is target layer.
Yeah.
So source layer is what they're taking, and target layer is where they transplant it.
Yes. So
Yeah.
here they are transporting the early layers into the middle
Yes.
layer, and that works. So that's not.
So
the
maybe
thing
you avoid reasoning, but you avoid confusion as well, and maybe that works sometimes.
I think it kind of has to work by using reasoning, because the thing you are doing here, I was wrong, because you are not getting Australia here. You are getting the thing from what's the capital of the country where Sydney is located, like the early layers. So you are like taking something, taking this, like the mechanism I was thinking of how it confuses it actually doesn't make sense the more I think about it. So kind of has to be something like what they are saying though. Like there's something about the putting the representation from Sydney or whatever on the middle layers that makes it the reasoning work when this is not currently working because it's on the early layers, but it's not moving to it's getting lost before the later layers for whatever reason.
Oh, I see.
Yeah.
But it is memorized at that point, so it's not like it's giving a nonsense output.
Yeah. Well, for the 2 steps question, it's probably giving a nonsense output.
So in these models, are they usually just permeated with a bunch of attention heads and MLPs like all the way through? I guess I'm wondering, if I transplant from an earlier layer to a later layer, do I still pass through some attention blocks? Can I assume that?
The transformer architecture has the same stuff on all the layers. Like it's attention, then MLP.
Because maybe you can think of it as saying like it did badly when it had to go through too many attention layers, but when I'm going through like just the last few attention layers, it treats it as if it's a much smaller network that's just seen the word Australia.
Is it
I feel like the too many attention head issue was solved by methods like MAT or attention residuals. Those two kind of help solve the too many attention layer problem by adding attention on the residual stream layers themselves.
Okay.
What did you say again? What did Rembert say?
I think it says that. Sorry.
Oh, I remember he was talking about how the too many attention head layer issue.
Yeah.
And I was like, methods like attention residuals and MHC serve to like help stop this because MHC basically stops this by adding more residual stream parallel.
Right. So my
Well,
explanation is probably
attention
not it
residual-
if it's already been solved.
But attention residuals in the
Interesting,
sense
I
like adds
just
attention
realized that.
onto the residual stream layers so that it helps like with the too many residual streams.
wait.
Like it
Yeah,
allows earlier
the-
signals to influence later ones.
Yeah, so basically there are just attention residuals should fix the issues described in this paper. Okay, that's funny. At least partially. Yeah.
Oh, actually, if you increase you do something. What was the thing that you said with increasing the regular streams? The skip connections or something? I mean to run
The
that.
attention residuals, you mean?
Yeah.
Yeah, that's like when you do it, when you input instead of just inputting the value at the current residual stream, you input some combination of previous residual stream values weighted by attention.
Okay. I wonder if those models are better at this kind of thing, and also what the effect of patching. Someone could try extend this
Yeah.
paper. Like if
So,
those
like,
are those models better at multi-step chaining and
I don't know, but the 3 trillion Kimi open source model has this architecture.
Oh, how much?
The 3 trillion parameter Kimi.
So it's state of the art then.
Yes. Well, right now GLM is state of the art, and it doesn't have that architecture, I think.
Yeah, well, definitely not.
It was state of the art for like a week.
Well, open source state of the art, not real state of the art.
Yeah, open source or open weights.
We will want to know what the true state of the art is, but we need to have the spice into Anthropic or something.
Yeah, we need to get into Anthropic, like Karpathy.
Yeah, just hire to Anthropic.
Yeah.
And then
I
you
have a
cannot
suspicion
talk on
that
the
the
Reddit group
safety
anymore because NDAs.
Yeah. Yeah. Completely banned from everything.
I think it's interesting, and it's possible that it's working the way they say they do, but I think it's kind of, I don't know, I'm not that convinced. I will need to see a lot more experiments on this to see how much. But it's interesting if it's true that there are some facts that are memorized. That if you put the memorized fact on the, like, that there are some representation of the capital of Sydney, Sydney is on Australia. Like, there is some Australia token here that if you put it on the middle layers, it outputs the correct thing. Like, we do know there are some activations that seem to be, like, from the Anthropic paper, that there are some motivations that are something like give the capital of this country, that you have these activations, and then you have some motivation representing a country, and it outputs the correct thing. No, if you change the country, and it's interesting that that kind of mechanism can exist on the model, and there can be facts, but they claim but those facts don't reach that mechanism. But apparently patching, you can patch and have it work. I feel like there are some weird things about these prods and stuff that makes me wonder if there is not some confounder or something that doesn't really work like that. But it's possible it does, and if it does, that's interesting. And probably there's something about how the models work. But
I guess I'm just surprised that this works at all, but I think that that's just my, me just having not heard of patching before. So maybe you guys are more used to it.
A lot of weird things in patching that you will expect to not work. Like, I think I kind of have problems that a lot of things work for a lot of weird hacky reasons that
empirical alchemy.
it's easier to confuse yourself into thinking they mean the thing you think they mean for the model, and they actually just not. But yeah, there's a lot of things like, I don't know if you probably also don't know how to steering, but steering works, and steering is when you
Steering.
like
Okay.
you take the difference of activations. Like, I don't know, you take some prompts where the model I don't know, does something that you want or don't want, like refuse things, for example. You take examples where it doesn't do that, you take the average difference in activations, and you add that vector to the activations of the model in that layer, and that
And then
makes
it
the
works,
model
so-
refuse more or refuse less. If
Oh,
you put
okay.
it in negatives. And that kind of thing just works surprisingly well. So there is a lot of hacky things you can do with activations that work surprisingly well. Like, turns out the models just are set up in a way where a lot of variables are some vector, some simple vector that is a lot of that is reused a lot through the model and does a lot of things, so you can do some like patching and have them work in very intuitive ways. And other times it just works in some very weird way that we don't really understand, and it's very confusing. But yeah, I don't know.
I feel like I would understand this so much more if they weren't introducing this with like a large language model. You know, if they're doing some simple like classification problem with like a deep net, and then they did this thing, and then they could interpret what was happening.
For patching and all stuff, there are some papers and examples from very toy models that you can probably look at to try to understand that.
Okay.
Like, this is probably not the best paper to start, you know.
Yeah, I mean, I guess it's established, so it makes sense. They're not gonna like you have to like you can't just do toy models forever. So I guess if it's established, then you would apply it to something.
The original paper for activation patching was for LLMs already. So it was this one, which is the locating and editing factual associations in GPT, which was from 3 years ago. Where this is the famous paper where they patch ROM to say that like the tower if
wait.
the default tower is in ROM.
Isn't this the one with weight editing, or that's a different one?
No, this is where they came up with activation patching.
Okay.
What's the name? Locating and editing factual associations. Okay.
Feed forward weights. They modify feed forward weights to update specific. I think this one is updating weights.
Okay. Maybe maybe I'm confusing with something else.
Yeah.
No, but it's not tested because we first deployed a intervention for activation in neural activations that are sensitive to the factory predictions.
Oh,
yeah,
so they do both. Okay.
Yeah, that's the activation part.
Okay, so they do both. Yeah, that makes sense.
And this is the causal tracing part. Intention activations for tracing information flow. They highlight the activations. But yeah, I mean, there are some anthropic papers and stuff. There are some things from toy models with like the Grokking paper that do some activation patching. I've done some activation patching on toy models. But yeah.
Cool. Okay. Well, yeah, that's fun.
Like there are some I have like on my paper that I published, there was this, we had this plot where we were doing patching. We have a model that has like graphs and finds paths in graphs, and we were doing patching on different layers and to see what register token patching, for example, on different examples and see how that changed the thing. Yeah. But yeah, a lot of the literature is in LLMs because the LLMs are the thing that people actually, use and whatever.
Yeah, makes sense.
And then people are more skeptical these days at how much things from toy models generalize to LLMs. Though I think part of this is just Neil said that he was less interested in that. A lot of people listen to him.
Well, more people should listen to Leo Gao then.
I mean, I don't think Leo Gao is saying a different thing though. Leo Gao also wants to do things on bigger LLMs, but he wants to do those sparse models things and try to interpret those now.
But I like broadly the ambitious interpretability.
Yeah, that's true. But I think this is separate from like that. That is. I mean, you want to do ambitious interview. You can also want to do it eventually on big models,
Yeah.
That's the ambitious part, even so.
Yeah.
Yeah, I guess I just feel like the metrics of knowing when something is generalized seems a little bit, so something I was kind of wondering through this is like, how do they know, how do they test the accuracy? Do they like prompt it, and if it says something kind of close to copper concentration or whatever,
I
now it's generalized?
They are
it's just fact. So if it's just fact here, so like if it replies with Canon Birea or Sydney or whatever,
I
then
think
it's
they
correct.
just have there's a single word fact, so I think they're just taking the probability of that word. Like here, they need to answer these things, so they probably it's a single. I think they just inputting this and then taking the probability of the correct answer. And if it will say it in another way, then that's a problem with the method. But it's this is a typical thing on papers.
Yeah, usually you say in the system prompt the format that you want the answer in for these kinds of evals.
Yeah, that's another thing. Oh, here this. I mean, you can just take the difference of like if it's a yes or you can also some people also do multiple choice questions. That's another way you can do it. Another way to
or you can use LLM as a judge.
Let the model write multiple tokens, but you then use an LLM judge to see if the answer is correct or not. But yeah, no, they are not doing that here. It has a new paper checklist here.
Yeah, I guess I always feel like it adds an extra layer of mysticism, almost. But I get that you kind of like the questions to do with the LLMs in particular are like the relevant questions, so you can't really move too far away from it. So I understand why people just go directly there.
Yeah, everyone talks or tries to. Oh, well, not everyone, but it's the majority of research right now.
Anyway, is there anything else you want to talk about this paper, or do we end it here and we go to try to figure out what we are going to read for next week?
I'm fine with going to general.
Okay.
Yeah, I'm happy.
No one is here. Nobody left. Yeah, most people left, so let's end the recording.